What's up, everyone? Good morning, good afternoon, good evening. Welcome to our second installment of our series. My name is Christos Matskas, and I'm a program manager for Microsoft Identity. And on the other line, we have...
Hey everybody, I'm John. Christos and I work on the same team. We work for the Identity Group. So if you've ever used Azure AD for signing into Office or Azure or signing into your Xbox, you've probably touched one of the systems that we work on. So today we're going to get into application types in Microsoft Identity.
Thank you for watching.
Okay. I want to thank all of you for watching. Thanks everybody for watching. I don't know what that was, but anyway. So today we're going to get into the second installment of our Learn series. And if you're not familiar with what a Learn series is or what a Learn module is or learning path, Christos is going to talk to you about that in just a second. But today we're getting into session number 2 of 5, which is all about application types in Microsoft Identity. And you can follow along with the link that's up there at the top. And this is a learning path. So these are parts of the Microsoft Learn stack where you can go out and do interactive, hands-on work to learn all sorts of different things about all these different parts of Microsoft services, be them Azure or Office or Identity or whatever. We have these Learn modules that you go through, and then we bundle a bunch of them together into a learning path. And today we're going to be getting into the second step, which is application types in Microsoft Identity. So what are we learning about today, Christos?
Today, we're looking at different application types at Microsoft and how we can build authentication around them. We'll look at OAuth 2.0, different flows, and when they apply best. We'll evaluate which authentication protocol is the best, depending on your app. And then finally, we will show you via demos how to do that. These demos that we will do today will actually be the same code that you'll be writing when you do the MS Learn module yourselves. You can also follow along if you want. We already put the link up there, and you can search for our modules on the Learn website. The important thing here is that we're here to explain, so make sure that you ask questions. We're live and interactive. In fact, right now, I'm in a boiling Seattle where the temperature is 84 degrees Fahrenheit, or to speak in non-freedom units, it is around 30 degrees Celsius. So it's a very hot day. My aircon is running just to make sure that I don't boil halfway through the session. It is live and interactive. Let us know where you're watching us from. Let us know how much you understand about identity. And then if you have any questions as we go through the module, then let us know. We'll spend time at the end of the module answering these questions and helping you out. And now all back to JP, where he's going to start with some awesome SPAs. Let's do this.
Yeah, so we're going to look at 3 different types of apps today. So we've got single page apps. These are things that run in your browser, right? So this might be the React app, Angular, Blazor, Wasm, something like that. We're going to take a look at normal web apps. So web apps that have a server that sits somewhere, right? Normal. I know everything's JavaScript now.
Yeah, normal.
Everything's JavaScript now, but the normal web apps are the ones that run on servers. We're going to look at web apps that call APIs. So this could be something like a Node app or an ASP.NET Core app that's going to call an API, and it's going to be a web app, so it's going to be running on a server somewhere as opposed to running wholly inside the browser. And then we're going to look at daemon apps. And last time we did this, there was a big discussion around, is it daemon, is it daemon, is it daemon? And I still don't think we have anything. So tell us what you think.
Tell us what you think in the chat. Yes. And also,
we need a poll. Yeah.
We need a poll for this, I know. But just to be clear here, we only have time to look at these 3 types of applications, but there are a lot more applications that the Microsoft Identity Platform can cover, like mobile. So even though we're not showing it here, doesn't mean that because it's not included, it's not supported. We're just going through the most common ones, I guess, in my mind. Let's do SPAs.
Yeah, the things that most developers are going to hit fairly early on, and the things that are that probably have the broadest appeal in terms of the tools that you need to get started with them and everything else. So let's start with single page apps. So single page app, SPA, you'll hear them, especially, I hear that a lot at Microsoft. I don't really hear it a lot everywhere else, but single page apps, these are things that are using some sort of client-side framework. And the key here, and the reason why these are a separate type of app is because they run inside your customer's browser, the security context around them is very different than, say, a web app that's running inside of your web server. And so these are things that are where the application code itself is written in JavaScript or in JavaScript in most cases, but also could be things like Blazor Blazor WebAssembly that run in the browser. All of those bits are going to be pulled down to the user's browser and executed down there. And so because of that, we have some kind of weird trust relationships that we have to deal with, and that's why we have to treat these as a little bit differently than how we would treat a normal web app. So for that, we're going to use something called MSAL, which is our primary sort of core authentication library. So there's an MSAL for most major languages, most major platforms, be it JavaScript, .NET. There's a preview MSAL for Go. There are all sorts of different MSALs for Java, for Node, for all sorts of different platforms in Java. But the key is that the MSAL library comes in two versions. So there's an older version called MSAL 1X, and that handles something called implicit flow. And we're going to talk about that here in a few minutes.
I have a question.
You don't want to use it. Yes, sir.
What is the difference between implicit and auth code?
We're going to talk about it in just a minute.
I'm excited,
Yeah. So there are two versions. We've got implicit, which we're going to look at here in just a sec. And then we've got what's called the authorization code flow. And this is actually authorization code flow with something called PKCE or PIXE, which is a different way to interact with an authorization system or an identity system. But for you, if you're using MSAL, you don't really know or care that that's being done because the library handles the heavy lifting for you. So, Christos, your question, what is implicit flow? The big thing about implicit flow has been around for a while now. It's part of the OAuth 2 spec. But the key thing to remember is that everything's happening in the user's browser. So the user's sitting there, they go to your app and they say, hey, I need to sign in. And when they sign in, they get redirected over to Azure AD. So this is pretty familiar if you've ever used things like Google sign in or Facebook sign in or Twitter sign in or any of these different federated identity systems. But the key is that I'm in my browser and I go to what's called the authorization endpoint. And the authorization endpoint is where the user signs in. So the user's going to get over to Azure AD and they're going to sign in, tap, 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 type in their username and password. And then their data is going to come back in the browser, back to the single page app, back to the JavaScript app. And the reason that's not entirely desirable is because there are lots of different ways, because this is happening in the browser, of course, there are lots of different ways that data could, say, be intercepted, that it could end up in places where it shouldn't be, like in logs. And so we're going to send a token back in this initial request, and that's going to live in the user's browser. So it could be in their history. It could be in a proxy, like if they're at work and they've got a proxy that's capturing URLs and all that sort of stuff. It can show up in a lot of different places. And the other thing, too, is we can't really verify that the application that asked them to sign in is actually the application that's signing them in, which can have a whole lot of problems when you think about, well, oh, this looks like a totally normal sign-in page for me, but turns out it's actually a malicious app, or maybe a malicious app on my desktop, or a malicious extension in my browser that's causing this UI to show up. So implicit, while it was great for things like JavaScript applications, it also caused a lot of problems, especially as browsers have modernized. So as things like Apple's made changes in Safari, I think they were one of the first ones, they would block a lot of the ways that we would get tokens in an ongoing manner, things like blocking iframes, blocking third-party cookies, that sort of thing. And so this is where we get into like why we should avoid it. And the big thing, of course, is the token leakage that happens up at the front by virtue of the fact that the data is sitting there in the URL itself. But we're getting to a point where if you expect people to use your apps on like modern devices, your iPhone or your Android phone or your relatively modern Windows or Windows PC or whatever, the browsers are going to start blocking this to the point where it's just not going to work that well anymore. If you work at a big company, chances are if you try to go set up implicit, somebody's going to complain. Somebody in your security team or somebody in your network access team is going to complain and say, whoa, why are we using implicit flow here? And so it's something that we don't necessarily want to. We don't want to enable it if we don't have to. And we're going to get into some of that earlier. So we do have one quick question, which is, does Microsoft Identity have any relation to RBAC or role-based access control? It absolutely does. So Azure AD itself handles RBAC as part of the work that it does. So not only does it assign people in, it also issues tokens for them to call other services, and it also handles as a sort of a role membership database. So you can add users to roles and define roles and do all sorts of fun stuff. So if we can't use implicit, what can we use? This is when we get into
what can we use?
Authorization code with PKCE, which is proof key code exchange. And what happens here, and it's kind of funny that we go in this order because authorization code has been a server-side thing we could use for a really long time, and we've had to adapt it to work in the browser. But the big thing that we add here is the step 5 up here. We have the server channel, we have this back channel call, where in our implicit example, we're going to Azure AD, and we're coming back to the app, and we've got the whole payload there. Instead, in the authorization code flow, we're going to go to Azure AD, and Azure AD is going to give us a one-time use code. And then our app in the browser is going to handle talking to Azure AD separately to go and redeem that code for an actual token that can be used to either know who you are or access other services.
So first, the user gets redirected to Azure AD to sign in, right? Username, password. Then Azure AD will send back a code instead of all the information. And then the application will use the code to validate the user. But the user doesn't have to do anything. It all happens behind the scenes, right?
That's right. The user doesn't have to do anything except for whatever their admins have said they have to do. They have to use MFA, or they have, on their multi-factor on their phone or something like that. And you as a developer, you don't have to do anything here either. Just upgrade your library from MSAL 1 to MSAL 2, and this sort of just works, right?
Nice.
The one additional thing that happens here is we use what's called a code challenge, and the code challenge is where the PKCE part comes in. So your app's going to sign or hash essentially a secret piece of code or secret piece of data. We're going to send that over to Azure AD during the initial sign-in, and then the app's going to send that back in its unhashed form along with that one-time code that it's going to redeem. And that way Azure AD can see that the app that requested the user to sign in is the same app that's actually redeeming the code and going to receive the tokens. So it's a little bit different from sort of traditional authorization code, but it offers a lot more security in terms of the round trip. And if somebody may be stealing that authorization code or similar, it offers a lot more protection there, because it's sort of like we were talking about the other day, Christos. If I sent you a text message and then I immediately call you at the same number and say, hey, we'll read that text to me, all that really means is that you got the text message that I sent and that you're holding the phone, right? So it's a little bit different from a long-term password or a long-term credential that we might use, but it does give us a little bit of extra security. So let's get into a demo on single-page apps. And if you're following along in the Learn module itself, you will have this code available to you. So what we did is we took the code out of here. We just took the code and added it to an existing project, so you don't have to watch me type. But the code that you see here is the same code that you're going to download and run if you are going through the Learn module. Yep. First big things that we need to do is this auth box. So this is just in the index, which is where all the script is anyway. This is just in the index. And you'll notice we've got 3 pieces of data that we need to provide: a client ID, an authority, and redirect URI. So Christos, what is a client ID?
Client ID is a GUID that you get from Azure AD that represents your app registration, the one-to-one mapping between your code and the Azure AD app registrations, which shows intent.
So we're going to register an app. So this is from the Azure AD dashboard. You can get to this from portal.azure.com. You can also get to this from aad.portal.azure.com. If you don't have an Azure AD directory that you can use, like at work or at school, if you don't have one, you can get a free one that's got a bunch of sample data and all sorts of stuff in it at the, I think it's called the Microsoft 365 Developer Center, which if that's not a Microsoft named thing, I'm not sure what is, but if you go search Google for that mouthful, you will see, you'll find yourself a free developer tenant. So first thing we're going to do is register this application. We're called Learn Live SPA. And you'll notice we have things like which accounts can sign in. We're only going to worry about single tenant accounts right now. We've got a session a little bit later on where we talk about the differences in all these different tenancies. And we have this redirect URI. We can put it in here, or we can put it in later, and we're going to put it in here in just a minute. Just in case you forget to do it here, you can always come back and add them later. So we've created our application. So now that we've done this creation, we've got one. It's called Learn Live Spa. We can go look at it and change different things about it. The first thing we need to do is go to authentication, and here's where we're going to add a platform. This is where we're going to say, hey, Azure AD, this app we're building is a single page app, and single page apps have some special features, we'll say, primarily cores. So if you've ever had cores issues before, since we're going to be making these server calls from your JavaScript, we need to configure cores essentially, which we're going to do. So we're going to add a platform, and we need to notice we have web and single page, and we're going to choose single page. And choosing single page here is of course very important. Now, because we're doing dev right now, we can use localhost, and you can also use HTTP, because you can't use HTTP with anything but localhost. It'll just bomb and say sorry.
Only for development, right? That's it.
Yep, only for development.
Good.
And we're going to use port 3007 because for whatever reason, the samples that are in here use port 3007, presumably to avoid conflicts. But we're going to use port 3007 because that's what the sample uses. If we go down a little bit, you'll see these two checkboxes, access tokens and ID tokens, that we want with implicit grant. Implicit grant, of course, is the thing that we mentioned just a minute ago. We don't want to use that if we don't have to. And it tells us, hey, your redirect URI is eligible to use authorization code flow, so we don't want to do that. So we don't want to use implicit if we don't have to, and we don't. So we've got localhost 3007. We'll hit configure. And now that shows up here. If we had another app or another like host that we wanted to use, say we're in production, we could always add another one here. If we have a dev environment, a test environment, we can always add that stuff here. So we've added that. Great, we're good. So let's go back to the overview. And this is our client ID. So the client ID that Christos mentioned earlier about the thing that tells Azure AD what we are, that's what we're going to use here. So we're going to go take this, plunk it in here. The authority is the Azure AD instance or tenant that you want to use. Maybe not tenant, but it's the instance that you want to use. The vast majority of the time, your authority will be https login.microsoftonline.com /common/organizations/JPDA, whatever the name of your directory is. So the authority, though, could be changed for really two main reasons. One, you're using Azure AD B2C. B2C is a totally different identity system here at Microsoft that we're not going to get into in this session. Or you are using what's called a sovereign cloud or one of the national clouds. So if you're using Azure AD Government, using Azure China, Azure Germany, one of the other sort of sovereign clouds, this authority will be different. But essentially, the authority is who is the person or who is the system that is responsible for telling us who you are. The common suffix there at the end is the thing that pretty much just says, hey, this is any Azure AD account can come and try to sign in here. And then, of course, for redirect URI, we already defined that earlier. So that's localhost 3007. So we'll get that saved up. Now, we should be ready to go. You think we're ready to go, Christos?
I think we're ready to go. It's good to know that everything should match, right? If you screw up one of these settings over here, then awful things happen. You get some error messages that you need to solve. So always pay attention to your configs because this is where usually things happen.
Yeah, that's good.
Yeah, let's do this. NPM start.
So I'm just gonna do an npm start, and that should get us up and going on localhost 3007. Now, npm is only being used here for the purposes of hosting these static files. So we're not actually hosting a web server, we're just hosting static files. So let's go to localhost 3007 and let's see what we get. So I'm just going to go to HTTP localhost 3007, and there we go. I'm already signed in because I'm already signed in this browser. So because I'm already signed in the browser, we didn't have to do anything extra. So I'll do it within a private window just so we can see exactly what it looks like. So let's go to localhost 3007.
Yeah.
And we can see that it is, sorry, I've got somebody beating at my door. That's why I don't like doing these at night, because my kids are home.
Somebody wants to enter?
Apparently so. So when we hit sign in, we get this pop-up window. And here, I'm just going to type in my username. And it's going to ask me for my password, which we'll go ahead and get signed in here. And you'll notice, too, it's also going to ask me to sign in and do multi-factor. So I've got my phone. Yeah, and so I've got my phone, so I should be getting a notification here on my phone that I need to approve my sign-in. Now, you'll notice we didn't write any code for anything MFA related. We didn't do any of that. All we did was go and try to sign in. And so because MFA has already been set up on my phone for my organization, because my people handle it, that's what's gonna do it. So when we get signed in, we get asked to do things like, hey, you need to open, you need to go and authenticate. So I'm going to go and authenticate. And I should be getting signed in. So now I'm not entirely sure why I'm not being signed in, which is a little embarrassing. But anyway, so once we run through the code, you'll see that we get signed in, and then we can go and make calls to Graph, or we can get tokens to go and call other services, and those are the ones that we do. That's what we do for.
Do you want to show very quickly the sign in sign out code, because it's literally 3 lines of code, and that's always what I like to demo when we do these things. How little effort it takes for developers to do that, right?
Yeah, sure. So, and this is the code that you're going to get out of the thing here. So, the big thing that we're going to be looking at is this MSAL object. So this is our public client application. Public client is sort of a magic word here, because public client means this is a client that's running on somebody else's machine, essentially. But as we go down, we notice we've got this acquire token and get user emails, which we're going to come back to here in just a sec. But there is a login method somewhere down here. Here we go, sign in. And for sign in, all we have to do is add this login pop-up. So that's it. MSAL application, login pop-up, and then we have our little bit of configuration, which just says what kind of services we'd like to go and access. And then once that happens, we go and handle the response. And handling the response in this case is just showing my name. So welcome username. And then you can also do redirect. So if you're not into pop-ups, we know pop-ups, a lot of people don't like them. A lot of people block them. They can cause all sorts of drama and issues with other things. You can also do a redirect. And of course, redirect, you'll get redirected over to the other application, or redirected over to Azure AD to go through the sign-in.
Just remember that
super simple to get this wired up.
And some platforms don't support pop-ups, right? I think it's Safari and mobile that did not work well with pop-ups, and we had to use redirect for that. So that's why we support both options. Sometimes you have to, sometimes you choose to.
And there's some other things too, like in Chrome, if you don't like click a button, for example, or do something that registers your intent to have something happen, then pop-ups get blocked and all sorts of things like that. So there are all sorts of things that can come up that can cause these issues. So let's get back over to the deck.
Yeah, what did we learn with this demo?
So we had our single page app. We created our registration, and then we updated our web page with those three bits of data, and then and away we went. We were ready to go. So we updated our data. We updated our settings in there, and then we went and tested the app. So now we're here to our first knowledge check. And we do have a question. Can we customize the login pop-up? And then also there's a question about auth keys that are used for any type of symmetric encryption, or is that solely the remit of SSL and TLS? The pipe is secured with SSL and TLS, of course, back to Azure AD. The tokens themselves are not signed with the TLS certificates. They're signed with a separate set of keys, and those keys are managed by our platform. In the case of SAML, you can use your own keys if you need to provide your own signing keys. But for OpenID apps, which are what these are, OpenID and OAuth apps, those keys are
signed by Azure AD.
Owned and managed by us. Yep. So we own and manage those keys. And then the signature, of course, we publish the metadata so that your libraries and tools can go and download those public keys and verify the signatures that are in the tokens. There's a second question too. Can we customize the login pop-up? You can customize the background photo. You can customize the logo that's up at the top, the banner logo that's up at the top. You can customize the text that's in the thing that says like, oh, you should sign in, or type in your employee ID at blah blah blah. You have some customization. It largely looks the same. The bulk of the customizable stuff is in Azure AD B2C.
Yep.
Okay, so let's get into our knowledge check.
Let's see if people have been paying attention.
So, which of the following options is not a characteristic that makes spas stand out from web apps? So, is not. Remember that, because that always, every time we do this, I always mess these up.
Yep.
So security characteristics of these apps are different from traditional server-based web apps. Okay, I think that feels true to me. I mean, JavaScript-based client-side solutions don't have the ability to process the authorization code used in the other OAuth 2 flows. That's a mouthful. So we're saying that one of these is not true, but then they all have negatives all throughout them. Let's see. The full page browser redirects away from the app and is invasive to the user experience. Well, I think that's subjective. Maybe it's not invasive. What if the app is so bad that the login process is actually the best thing about it? It could be, right? And many authorization servers and identity providers don't support chorus requests. Well, I think that one is sort of demonstrably false. So what do you think, Christos? Where are you feeling? How are you feeling on this one?
I feel like a B to me. So JavaScript-based client-side solutions don't have the ability to process, which we know they do. Right?
Yeah. So if we cancel out all the negatives there, what we're essentially saying is that B is the correct answer because B is false. Because they do have the ability to process authorization codes. Okay. And of course, look at that. You're right.
Wow. I get to keep my job.
Yeah, we both do this time. So the next one, why is an application secret not required when authenticating with Azure AD in a SPA? And we didn't really talk about this, but why would a secret not be required? Instead of using a secret, we could use a certificate. We have to use one or the other. Okay. They aren't needed because the user's password acts as the Azure AD app secret. That's an interesting one.
Yeah.
Secrets can't be reliably secured in a SPA because it is inherently a client-side application, and in no scenario can the secret reach the user's browser and be secured. Which one do you think, Christos?
Well, we just talked about why implicit flow is not good and how things are available on the client-side apps. So I guess C is the one that makes more sense, right? You could still use an X509, which would be slightly more secure, but doesn't make sense. And Azure AD passwords acts as an app secret. No, that's never the case. The app should never know user secrets or passwords whatsoever. So C is the most likely the right answer. Do we get to keep the job?
I think you're definitely right there. Yeah. So we talked about spas. You ready to go? You ready to talk to us some about traditional web apps, if we want to call them that, even though that's probably a misnomer?
I don't know. Yes, let's do this. Let's switch to my screen. Let me share my screen, and then we'll do this. I forgot to share. Yes, let's share. Okay. Too many monitors, my friend. That's the problem. Okay. So we're sharing SPAs and web apps. They're both available on the browser, and they're both available by the user. So they're not, I wouldn't say traditional, but probably more mainstream because we grew up building server-side apps for a very long time. So web apps that can sign in users and call APIs. Yes, with the Microsoft Identity Platform, you can secure your Java, your Node, your Python, and your .NET, whichever web framework you're using to build your server-side web apps can be secured by Microsoft Identity. And Microsoft Identity allows you to do two things. One is to sign in the users, first and foremost, which is important. And then once we sign them in, we can use the OAuth 2 protocol to go and request access tokens for other resources. These can be your web APIs that you want to secure. This can be Microsoft Graph and Microsoft SharePoint and Microsoft OneDrive or whatever you want to access there. Or this could be also Azure. So we allow you to not only know who the user is, but also what they can do within your application. So adding authentication is usually pretty straightforward. It requires a few steps. And with authentication, we can customize the experience to the users, greet them, personalize the sign-in process, personalize the pages, and then also deduct from there what they can do. So in web applications, we also have implicit flows or hybrid flows, and we also have authorization code with Pixie as well. So you might still get a mix of experiences, but the web application still redirects the user to the sign-in page in Azure AD. And then there the user signs in, and Azure AD will return a response back to the user's browser or the application. And that, depending on the flow that you're using, it could be implicit, like hybrid, or auth code with Pixie. And with that information, the application signs in the user, and then they can also use that information to go and request an access token if that is configured to call APIs on behalf of the signing user, which is great because it's very common. So this is the flow that you see here. The user comes onto the page. It's an unknown user to the application. The application says, well, to access specific pages or specific parts of the app, you need to sign in. So it redirects the user to Azure AD as part of step 2. Then there the user has to sign in. So the user never provides credentials or personal information to the web app itself. It does everything on Azure AD. And then Azure AD is responsible for validating that information, apply additional configuration settings like MFA or conditional access to make sure that the user can log in and can sign in with the right information. And once that happens, Azure Active Directory returns back a one-time use code to the server if you are using the auth code flow. And then the browser or the app uses that information at step 5, which is at the very top, to go back to Azure AD on behalf of the user and grab the ID token. And then at that point, Azure AD says, okay, I can issue you an ID token and maybe an access token and return them back to the user, to the application. So the user only has to do one activity, which is signing in, and then all these dance happens behind the scenes, and it's usually instantaneous. You don't really see that. It's like signing in, press submit, and suddenly you're redirected back to the page and everything's done. So even though there are quite a few steps there, most of the users don't see that. And the nice thing is that you as a developer also don't have to see that. Like, I'm saying that it depends on how you want to implement OpenID Connect and OAuth 2. If you're using the MSAL libraries that most of our samples are using, then technically you don't have to do anything other than configure and run the code as it's provided. But if you decide to roll your own OAuth 2 or you have your own OpenID Connect libraries that you want to use, then you might be a little bit more involved in the steps and you may need to understand them. We don't want our developers to spend days, weeks, or months learning about all these because they are provided to you for free using the MSAL library, by the way. And with that, I think I spoke too much. I think we might as well just jump into a demo and show you how to do this. Again, we don't want you to see us writing this code. We wrote based on the samples that we have on the Learn module. So I'm going to actually skip the process and spare you the pain of seeing me copy pasting and typing all the information. But let's start with this is a standard ASP.NET web app. Sorry, it's a web MVC application that calls into the graph. We're using graph because it's always an API that is available to us and easy to demo things, but you don't have to use graph in your real world scenario. You're most likely using your own APIs, but it helps to get us off the ground very quickly. So very similar to what JP showed in his demo before, we start with the configuration. So as you can see at the very top, lines 2 to 8, we have some information there. You'll also see I have a client secret, which I'm disclosing here, which I'm going to delete right after this demo. But you'll notice it's very different because this application is running on the server. We can actually provide some secrets there, so we can go and acquire access tokens and have a confidential relationship between the app itself and Azure AD because they know each other. So I still have a tenant, I have a client ID, and then I also have my domain that we use to identify where to go to sign in the users. Because this is a single tenant app, in the same way that you will be building the application if you go through the sample, we need to tell exactly which tenant it needs to go to. Otherwise, it will have no idea how to redirect the users and where to redirect them or where the users should exist unless you create a multi-tenant app. The next step in setting up authentication is to go into our startup. And in here, within a few lines of code, we're able to not only configure authentication, but also tell the application that we want to acquire tokens, access tokens for our graph endpoint. And then there's a helper method here called add Microsoft Graph. This is part of the Microsoft Identity.web library that more or less bootstraps Graph for us. So we don't have to bring the Graph SDK separately. We don't have to create a wrapper or a service for interacting with Graph. It's actually built into the framework. And then finally, on line 36, we add a token cache, which is nice because while the application is running, we don't want to be going every time to Azure AD to request an access token and then come back and make the call. We're caching it. Usually this works very well for testing because it's in memory. If you are deploying this to production, there are other token caches out of the box that you can use, including a distributed token cache using SQL or Redis, and even a session cache if you prefer to use a session and your application is designed around that. So we have configuration. Now you'll notice that this configuration that we had before on our app settings, it's called Azure AD. It gets passed into our startup, and then we have some scopes here for Graph to request. And that's it. And then we have one controller called the user controller. So once we sign in, we can redirect the user to this controller. And when we hit the index or the home one, it goes into the Graph client and does a request to retrieve the user information. And in the view, we're not doing anything special. We're just displaying the username. Graph brings a lot more information. If you ever had the chance to use the Graph Explorer, then it brings a lot more information, but just for display purposes here, we're only showing you the display name. So let's run the application and see what happens.
The anticipation.
It's killer. Will it run? Will it run? Who knows? So there you go. I'm already signed in. I can actually sign out, and I'm not going to go all the way in, and then I'm going to go back into my localhost 5001. And here it says, well, you're not signed in. Would you like to sign in? I will say yes. And I do have MFA switched on as well. So if I was not signed in anywhere else, then it would prompt me for 2FA. I don't have my phone with me right now. I don't want to jump halfway through the learn module, so I'm not going to test that. But trust me, there is an MFA here, because that's what I've configured to my tenant, and it only takes a few steps. Again, nice. As a developer, you don't have to worry about that. So let's go into the user controller, and there you have it in all its glory. It takes very few lines of code.
Your display name, yeah. So your display name came from Microsoft Graph. Now, what is Microsoft Graph?
So Microsoft Graph is a Microsoft API. It's the one API to rule them all. It allows you to interact with Azure AD. It allows you to automate quite a few tasks around Azure AD, but it also becomes the portal to things like OneDrive, SharePoint, Dynamics. Most of the organizational data that you might have goes through Graph and allows you with one API to work with all these different components of your organizational data. So it's a fantastic API to work and use. And, most of our demos involve that because either we use it as admins or we use it as for display purposes, but it's great. Now let's very cool. Let's go back into our deck. Yeah, if you haven't worked with Graph, I would urge you to use Graph Explorer because it's a fantastic tool. So here, let's go back into our slides. Cool. So what we saw here is an application which was a single tenant. It was only using one Active Directory to sign in users. We created a client secret, which I've shown you, and I need to go back and delete it. Reminder to myself. And we signed in through our web app, our MVC web app, and then we use the user controller to just retrieve some data from Graph. That point is very important. Once you do that successful call to Graph, the sky's the limit because everything else becomes available to you through the additional scopes that you add. So I think it's time for some knowledge test. What do you think, JP?
Looks like it. It's that time again.
And I was way too fast with my clicking here. So let's see, which of the following unique characteristics of the authorization code grant flow, so many words here, make it a preferred option for securing web apps? So why is authorization code flow the preferred way? The web app never has access to the user's credentials because the user signs in with Azure AD and not within the app. All communication between the web app and Azure AD is secure. This also sounds true, right? I mean, it has to be secure over HTTPS. And the web app authenticates with Azure AD using an X509 certificate when updating an access token. Well, this also sounds true to me as well.
I mean,
So
you could use a certificate, but it's not a requirement, right?
No, correct.
So, but I guess the question is unique characteristics.
Unique
right?
characteristics. That's true. Yes. So I hope you've
my
been
vote
paying
is
attention.
my vote is for A.
Let's see. And yes, we both get to keep our jobs for one more day at least. Or at
I
least
guess,
yeah, go on.
well, because things like implicit doesn't have access to the user's credentials either, but I guess things like ROPC, resource owner password grant, I guess those would you would touch your user's credentials then.
It's
But
the one flow that we don't talk about.
yeah.
The one that shall remain unnamed.
Yeah.
On to the next one. What elements are required to create, configure, and or collect when registering an Azure AD app registration to use with OAuth 2.0 authorization code grant flow? Tenant ID, application ID, application secret, and redirect URI? Or is it application ID, application secret, and the redirect URI? Or finally, tenant ID, application ID, and the application secret? Interesting. I mean, we saw some of that in our demo, and hopefully people were paying attention as I was explaining what and why. But what is the minimum, right? People are saying A, some people say A. Yeah.
I feel like this should be like a matrix. So it's like,
yes,
some of these are in every single one of them. So I guess we can say unequivocally, you need an app ID and an application secret.
That is true. Yeah.
So, I'm fairly certain that we're looking at A because it's single tenant, right? So we need to know the tenant you're signing into. So that's my vote, A.
But they didn't have single tenant in the question, which is interesting, right?
That is interesting.
That is interesting. So it is A. Well done. Well done.
Very good.
Very good. We're keeping our jobs and we're moving on to the next exciting thing that JP is going to talk about, which is, I think it's Daemon or non-interactive apps. We still don't know how to pronounce it, so excuse our.
Yeah, we need a poll. We need a survey. If it's Daemon. It's like that one Tool album. So Daemon and interactive apps. We could also call them headless, I guess, if we were so inclined, because it kind of the same thing. Services, headless apps.
Yeah.
Yeah. So basically something where you don't have a user sitting there waiting, right? I mean, that's kind of the net. It isn't an interactive application, right? Well, let's answer this question before we jump in. Can we use Google or Apple IDs to authenticate the user? So, I mean, we've got 90 minutes today, so we can take a while, but
we can do it. We can do it.
So in Azure AD in Azure AD B2C, absolutely, you can use Google and Apple IDs with B2C because B2C is geared towards social stuff. But in regular sort of normal Azure AD, which is what we're talking about here, so apps you're building for work, apps you're building for school, that sort of thing, we can use Google sign-in, but it uses something called external identities, or you may hear it called Azure AD B2B. And really what you're doing is you're inviting a guest into your directory. But the key there is how you interact with that user, what their relationship is with you. And so if you think, well, I want to invite a Google user to come and work with me on something, well, okay, that makes a lot of sense. But if I'm building an app for any Google user to go and use, maybe we use B2C instead of using regular Azure AD. So,
So the short answer is yes. Depending on your scenario, you may have to do different settings, but it is available to you. Yeah.
I mean, that's the thing about identity stuff, right? Is you can show up to a 3-hour session with 20 minutes of content and you still won't finish. So, just because it's every answer is, well, it depends.
It depends. The gift that keeps on giving.
That's
Identity.
right. So
yeah.
So we have built-in integrations with Google and with Apple on B2C. We have Google built in for regular Azure AD.
Yep.
Okay, so Daemon and non-interactive apps. These are things where, unlike a web app, there's no user sitting in front of it. It's not like a mobile app. It's not like a mobile app that's sitting on my phone where a user is tapping to log in. This could be stuff like integration scenarios or reporting where I need to go pull a bunch of data out at once. Or do you have any scenarios you've run into, Christos, that use these sort of non-interactive things?
Done it a few times on the stream as well, right? So automation, you want to automate some tasks and you want to run them. Sometimes we've done it through Azure Functions. Sometimes it can be a Linux daemon. Sometimes it can be a Windows service. But the point there is that if you need to interact with your services or your data, you need to do it securely. So you don't want any random app that any random executable to be able to call those services. And this is where this scenario falls very well into the security stuff.
Yeah, so with these kinds of apps, the app itself is the thing that has an identity. So instead of us using, say, a user identity to call the graph, for example, to figure out a user's display name or to read their mailbox or read their calendar, these non-interactive apps, because we don't have a user, they can't see a specific user's data. They tend to get access to all the data, say, in your organization. And because of that, they authenticate with their own set of credentials. So in Azure AD, you'll hear them called service principals a whole lot, where the service principal is essentially the securable part, right? That's the credential itself is the service principal's ID and secret or certificate, and then permissions are assigned to that. But these are Windows services, Linux system, system D services, things that are going to run all the time. Scheduled tasks, for example, like Christos said, we do a lot of these with Azure Functions. Your deployment pipelines, if you're using things like GitHub Actions or Azure DevOps, you'll use these because nobody's sitting there. So in some ways, they're kind of easy in the sense that you just have an app ID and an app secret, and you give it permissions, and it goes and does stuff. Most of the difficulty with the client credentials flow is not the actual flow itself, but rather the organizational process you go through in order to be able to do this. And the reason why it is more straightforward, and the reason why it is, I'd say, arguably simpler than the other OAuth flows, is because it's essentially a username and a password. It's just that it's for an application. And it's still for scoped access. So rather than saying, here's the username and password that gives you access to anything and everything, instead it's still scoped.
But you did say that there's a challenge, right, with the scope?
There is a challenge with the scopes. And the challenge with the scopes is usually an organizational issue of an administrator is the one who needs to consent to this. An administrator is the one who needs to allow this, because essentially you're saying, well, I need access to all of a certain type of data, potentially, and without more granular sort of role-based access control for those principals or for those service principals or users, it can be it can be a bit of a security problem to say, well, this principal, I only need to read one calendar, but I have to give it access to everybody's calendar because that's we don't know, there is no specific user, it's just this thing. Yep. And so good luck getting your administrator to say, oh, your app can totally have access to everybody's calendar when it only needs access to one. But yeah, client credentials flow itself is relatively straightforward in that all it is really is an API call that your application makes, along with its client ID and its client secret. The client secret could be just a string secret, like the one that Christos showed here a few minutes ago, and the one that we're going to look at here in a minute. In production, we'd prefer you use a certificate. And with a certificate as a credential, we are going to sign a bit of data to send to Azure AD as our credential. And that way, our private key that we use to sign that will never leave our machine. So it'll never leave our compute, our server, our Azure, whatever. It'll never leave that. You just send this signed assertion over the wire and the API call, and then Azure AD uses that to verify that the the caller is who the caller says they are. So let's do a demo of a daemon and non-interactive app. It is both of these
let's
things.
see it in action.
So let's go take a look at this. So we've got this is a C# app, C# .NET app, .NET console. Nothing too crazy from what you're going to see out there from what you're going to see out there in the Learn module itself. We've got app settings in our program here. We've got some little pieces of data that are going to go and get those app settings, and you will create most of this as you're walking through. So we're going to go pull our app settings file, and we're going to get these 4 bits of data out of here: the app ID and the app secret, the tenant ID, and the target user ID. Now, target user ID is for this specific application because we're going to go look at the user's mailbox, or go look at a specific user's mailbox. But app ID, app secret, and tenant ID are the things that we need in order for this to work. So let's go get this registered first. So we'll come back to my directory. I'm going to add a new app registration. If you don't have add here, you can always go to app registrations over here on the left side and create a new registration.
And I think it's important to say at this point, because console apps require admin consent 99.9% of the time, although 100% I would say. If you use the developer tenant again, it will be easy for you to start testing and going through the process. If you try to do it on your company's tenant, it's very likely that this thing that JP is going to show now will fail because you'll need admin consent. So make sure to set up your own Microsoft 365 developer tenant.
And I think we'll cover permission and consent in a couple weeks.
We are indeed.
And so yeah, then the net of it becomes admin consent, depending on the size and policy of your organization, can be very difficult to acquire. So we're going to register an app. I'll just call this one Learn Live Headless. Accounts only in this orgs directory, because these are the only ones that we need. Now, in this case, we don't actually really need a redirect URI because a user is never going to be redirected here. So we don't really need this. So we'll just skip it. We'll just leave it blank. So we have 2 of the 3 pieces of data that we need so far. So let's go ahead and move those over. In fact, I'm just going to move my browser here to the side, and we will do both. So I need our tenant ID. So the first thing we have here is our tenant ID. And in fact, you'll see this in all of your app registrations. It's already here, which is great. You can also get it from the overview screen of your directory in total. So I'm just going to go ahead and grab this and put this here for tenant ID. The dirty secret is that you can also use things like your directory's name or any custom domains that you may have set up. You can also use there for tenant ID. We also need the application ID, so we'll copy that. And the app ID is just the application's ID, so just the application's unique identifier. So we'll copy that in. And now we need an application secret. So for the secret, we've got our client credentials here. We can add a certificate or a secret. You've also got them over here on the left for clients and secrets, and we can upload a certificate, which we're not going to do today, or we can just go and generate a new string secret. I'm going to have this one expire tomorrow, just in case I forget to forget to delete it this evening. So we'll go ahead and add this, and I'll call this delete me. So I have a name that I can come back to and look at. So we'll add this, and here's our secret value, which we can use our little shortcut here just to go and copy. So get this, and we'll plunk this down in here. So we got our secret, we've got our app ID, and we've got our tenant ID. Now, this is the bare minimum we need to do an authentication trip with Azure AD with what the client credentials grant. The app also needs this target user ID, which is we're going to go call and get my mailbox or get a specific user's mailbox. So I got to go get a user's ID that has some mail. So I'm going to go back out to the Azure AD dashboard and see if I can't find myself. Now you could also go into the users list and get a user's ID. My user ID, because I'm signed in, is right here. So I'm just going to grab this one. So this 96201D, we're going to go ahead and put this in here, my target user ID here. So we've got this. We'll save it up, and let's just let's see if it works. I'm going to do a .NET.
Will it run? That's the question.
Will it run? Well, do I have any offensive mail? I hope not. So we got a hello world. That's encouraging, I guess. And no, it didn't run.
Oh,
interesting.
Did not run.
And it did not run. So it did not run because the token contains no permissions.
Done.
Now, why does the token not contain any permissions?
Did you configure your API permissions and did you consent to them?
Exactly. We didn't do either of those things. Let's go back to our app registrations.
Just making sure you're paying attention.
We called this one Learn Live Headless, right? So this is back under app registrations, and we have our display name here. Now, of course, it's telling me our secret's about to expire, but that's okay. Now, because this is a client application, when Christos and I did our applications earlier, we were asked to consent. We were asked to allow a sign-in, right? And that's because the two of us were there because we were interactive and we could go and do that, right?
Yep.
In a headless app, there is no concept of user interactivity because there's no user there to do it. So which means that a user cannot grant consent at runtime. We have to do that consent up front. So we're going to add a permission here. And because we're reading mailboxes, we're going to choose graph. And delegated permissions, these are ones for the user, right? These don't necessarily need administrator consent unless you're accessing sensitive data. So you're accessing, you want to write a user's files or something like that may require admin consent, or perhaps you want to inherit a user's admin permissions to something that might require admin consent, that sort of thing. For application permissions, though, application permissions are always going to require admin consent. So what we're looking for is mail. So I want to read mail. So I'll just search for mail because there are a lot of permissions in here. And all I want to do is read mail. So there's this mail.read scope that we can use, or permission that we can use. And of course, over here on the side, you'll notice it says admin consent required, and it's yes for all of them. Since all we want to do is read the mail, this is what we're going to use. But you'll notice it says read mail in all mailboxes. So not just a user's mailbox, but all mailboxes. So I'm going to add this permission. Now, it still says not granted. So if we tried to run this, we're going to get the same error, which is you've given me a token. The graph is going to error and say, well, you've given me a token that doesn't have any permission, because even though we've said we want this, until an admin consents, we don't actually have it. So because I'm an admin, we'll go ahead and grant this consent. Now the consent has been successful, and we get this nice green checkbox over here that says, yeah, that's cool. So let's go back and run this again. And hopefully those permissions have had a moment to have had a moment. I think we're just waiting. We got to give it a minute to let the permissions propagate. So, because it's the same problem. Token contains no permissions, or the permissions cannot be understood. So, this one more time. Hopefully, I have permission by now. And there we go.
Right? There you go.
Yeah. So now we've got permission. So you'll notice we've got emails like Azure AD Identity Protection Weekly Digest, and it was received June 1st, and blah, blah, blah. Buy a subscription to keep using your product. I have no idea what that is. Power BI news, events, and updates. Yeah, needless to say, this is not an email address that I use very much. I can view my Office E3 developer invoice, right? So we got access to my mailbox because we chose my thing. Now, if we look at how we did that, Christos had the advantage of the Microsoft Identity.web library, which of course is super clean and easy to use. With us, we ended up with ours. We're going to end up with something a little bit different. And again, your code is going to come through similarly if you follow the Learn module. But we have this IMSAL authentication provider, which is a very graph specific thing for the Graph SDK. And this is the thing that's going to handle going out and getting tokens for us. And so you'll see we have this acquire token for client. And acquire token for client is pretty much just that. That's the only call that we need to go get a token. We don't have to worry about callbacks or any of that silliness because, again, we're not in a browser. We're just a console app or a service that's sitting there running. And then we have our auth handler, and the auth handler is the thing that's going to handle taking the tokens that we get and then tacking that on to the graph request before the graph request goes out. And if we go look at the code specifically for our, if we go look at the code for creating the IMSAL that we're going to use, you'll notice we have three big things here. We have with the authority, which the authority is set right up here. You'll notice it's login.microsoftonline.com, like we talked about earlier, with the client secret, and then we build that instance, and that's it. Now we have our
still 5 lines of code.
Yep, still 5 lines of code, and then this is the thing that gets called acquire token for client, acquire token for client async. So, what did we learn in our Daemon and non-interactive apps? Well, we created an Azure AD app. We created the headless app itself, updated our console app to support Azure AD, added graph into the console, and then we built and tested the application, and we saw my mail that apparently one of my services is about to lose some data. So I should probably go and check that afterward. So you ready for another knowledge check, Christos?
Ooh, double negatives, bring it on. See, I'm telling you,
Excuse me.
double negatives. Which of the following ways isn't?
A valid authentication option for an app using the OAuth 2 client credentials flow.
Yeah.
Include the client ID and certificate assigned to the app within the Azure AD management portal.
Okay.
Include the client ID as well as the user account's credentials that act as a service account.
Okay.
Include the client ID and client password assigned to the app within the Azure AD management portal. Well,
Which one isn't
so
valid?
which of those isn't valid? Which of those is not valid, Christos? What do you think?
Well, just the fact that it said user accounts credential there just rings a lot of bells, my friend. There was no user to talk about, right?
That's a pretty solid B. B for busted.
Yes, and talking about that, I mean, ideally, when you're using confidential clients like that with daemons, we recommend always using a certificate instead of a client secret. Client secrets are great for demos, but not as good for securing apps in production. So credentials.
That's true.
Yeah.
And then, then the last one is include the client ID and the client password. So the client password is essentially the client secret, right?
Which is the correct answer. That's how you do it. We're looking for the one that it wasn't right.
Yeah.
Double negatives. Okay.
Okay. Now this is one we actually didn't cover.
Correct.
Which we can go
maybe
back.
We can spend a few minutes talking about that because it trips everybody.
Yeah, we'll go take a look. So, what minimal scope must a daemon or service app include in the access token request to Azure AD? A single scope of the resource followed by a .default, such as graph.microsoft.com, whack.default. Every scope added from within the Azure AD Admin Center, or nothing, because the permissions were statically specified on the app in the Azure AD Admin Center. Daemon apps don't need to include specific permissions in the access token request.
Let's see what the people have to say before we delve into explaining why and how. I think that's important.
Yeah, because we didn't cover this, so.
Yeah, I also like how they called Azure the admin center. It's an admin center. It's a portal, isn't it? Azure AD portal.
Well, it's the one that I've been using is the admin center too. So So anyway,
really?
So it is. Yeah, I think that's what it's called. We'll see it in a minute. So of course it is A, which is .default.
Yes.
And .default, of course, can be a bit confusing. Let's go back and look at the code that we just had up here.
Yes.
So when we're creating our authentication provider, we've got our base config, tenant ID, et cetera, et cetera. But we also have the scopes, and in the scopes, we are adding our .default here as the scope that we're going to.
Yes.
Now, if you had used Azure AD v1, or if you'd used the old library called ADAL, the only way that you could get permission to stuff was via the configured permissions. So the only thing you could do was come in here and add permissions that you needed. Part of the problem with that is, like, let's say I also want to write some files.
Yeah.
Let's say I'm like, oh yeah, maybe I want people in my app to be able to upload stuff to their OneDrive. So I need to be able to access their files. Well, if 10% of your user base is going to use that, they're going to be asked that up front. It's going to say, oh, do you want to give this app access to read and write your files? And most users, at least I would be like, whoa, hold on. Why do you need to read my files? You're just helping me do something basic. And that's the whole premise of dynamic consent. Is the developer asks when the developer needs a certain permission. So instead of having to declare them and request them from a user all up front, instead, we can ask for them as we need them. So if maybe you only need a specific permission super, super far down into your app, and it's only going to be a really small percentage of users who need it. You don't want to have that permission from everybody if 10 out of 10,000 users are ever actually going to use it.
Yep.
So back to earlier, in the case of a confidential, or in the case of a client credentials app or some kind of a headless or daemon app, the only thing we have, or the thing we don't have in front of us, is a user to do any sort of dynamic consent.
Mm-hmm.
So all we're going to do is make this API call to get a token, and we're going to request the scopes that we need in order to do that. Well, what if we haven't added those scopes? What if we haven't consented already? Well, it's going to blow up like it did before, but we have no way to ask a user because there's no user there. There's no user who's interactive. And so instead, what .default does is .default gives us everything that we have consented to for a specific resource. So note that it's graph.microsoft.com/.default. That means that everything that follows, that everything that all the permissions that we have that are part of the graph resource will be returned in that token. If we were to add a different one, say our own API, I'll just go to my APIs. Let's say we chose, we had our own API.
Mm-hmm.
We wanted to use, let's do to-do list service, because clearly we all have lots of to-dos, although that doesn't have any delegated permissions, but hopefully the next one that I pick will have them. So I'll do a test API, which also doesn't have any. I'll look at one more and we'll see if it's there. If it's not, then we'll just have to move on.
Give up. We're going to give up.
I know. I'll try one more, I guess. That doesn't have any application permissions anyway. Let me go find another one that's got an app permission. Let's choose, say, let's take a look at, does Azure Storage have any app permissions? No, it doesn't. What about Azure Service Management? No. I swear it's impossible to find one now. The Power BI.
Power BI or OneDrive.
Power BI has one. So the Power BI service is a separate resource. You can't access Power BI through Graph. So because of that, the resource ID itself is different. It's analysis.windows.net/Power BI/API. Analysis.windows.net is the resource here. So if we want to add this application permission, we'll say like tenant read.all. That's the only thing that they expose. Cool. So let's add that permission. So now we've got this permission. We grant admin consent as we would expect to. We have this application scope here, and we have this scope. Now, if we tried to use the scope directly, it wouldn't work. So what we end up with is in our code, we'd have to add, not necessarily here, but we would add a separate scope when we want to request the token, and that would be the analysis.windows.net/Power BI/.default. And so what this gives us is this sort of shortcuts the whole thing. And instead of asking for each scope independently, we're going to say, give me all of the permissions that I have consented for this specific resource. Because you still can't get a token for two different resources from a single request, right? You're not going to get one access token for both Graph and, say, your custom API, right?
Mm-hmm.
So what this gives us is, because we don't have users sitting in front of us, we have to configure the API permissions that we need up front. And by using .default, we're essentially saying, please give me all the permissions that I have already consented to, and you must use this. You must use this .default for client credential flows, and then also for another flow called the on behalf of flow, which is when your web app is, say, calling an API that's calling another API on behalf of the user. Okay, and we've actually got some pretty good docs and pretty good blog posts on what all those are.
That's true. We have
so let's wrap
questions
up
as well. Yeah.
Wrap up client.
Let's wrap up, and then we'll do the questions, you think?
Sure, go ahead. Go ahead, Christos.
Okay, the first question, Joe Silva is asking about customization. What are the additional customizations that you can do with Azure AD B2C? Where do we start and where do we stop?
Anything and everything.
You can do everything. That's true. There's a custom template, right? There's one template. There are some fields that need to exist in your HTML. So as long as you build these inside your own pages, because it's just a publicly available HTML page, that's all you need to do. Okay? You can add as much JavaScript and as much CSS and fully customize the experience to make it look and feel exactly like your app. You can go crazy with it. But as long as you have those predefined fields, so B2C can populate and use that template accordingly, then you're done. So we have a blog post, in fact, on the 45 show that you can go and see that. It's also in the docs. And we recently updated the template to support the latest jQuery. It's still available in 2021. It used jQuery to do some magic there, but it got updated to bring the latest security fixes in. So you can go as crazy as you want with those pages. Next question is for you. Can you talk to us about what's coming in the next sessions? Do you want to go back to the very original slide? There you go. Awesome. So we just covered application types, right? And
yeah, so next we'll do permissions and consent, which we already kind of started talking about a little bit. We touched on a little bit. So the next one, we're going to look at permissions and consent, which is all about how permissions are defined and granted and given and managed and dealt with. Then we'll look at how you're going to build your own APIs and secure them with Microsoft Identity, which plays a lot with permissions and consent. And then lastly, our last session, we'll look at RBAC, role-based access control and authorization.
Mm-hmm. And authorization.
Yep. So we've got
very important.
Yes.
Yeah.
We got for the coming weeks.
Next question is a doozy. What are the challenges for Azure AD in a real implementation? For Azure AD? For Azure AD, for developers, what is the challenge? Or for IT admins? Or I don't really get that question, but maybe we can try and answer that, right? So for IT admins, the challenge is to configure and make sure that they have the right conditional policies, conditional access, custom policies, MFA turned on, that every user has been configured accordingly, that they have been assigned to the right roles. There's still a lot of leftover from back in the day that we're using groups. If you're using a hybrid scenario with AD and Azure AD, then syncing all that. So for AD admins, there are quite a few challenges. For developers, not so many. As long as you follow the standards that we discussed today. So if you're building an SPA, now you know how to do it. As long as you use the libraries that are OAuth 2 and OpenID Connect compatible, then there is very little configuration and code that you need to write to integrate with Azure Active Directory and Microsoft Identity overall. So developers' lives are a lot easier because they get all the free stuff provided to them. Conditional access, multi-factor authentication, integration with other services, and end-to-end security, all out of the box. You just have to add a few lines of code. I don't know if I've missed anything, JP. Your take?
I would say organizational restrictions, or working with the rest of your org and getting the right permissions to do the right things. I think that tends to be something that hangs up a lot of implementations, is either falling too hard on the lock everything down and don't allow everybody to do anything side, or falling too far on the other side, which is just total Wild West with no governance. People are registering apps and granting permissions and doing everything sort of all over the map. But that's more of a people problem than a technology problem, of course, like people and process. I think identity is one of those things that a lot of developers aren't interested in. Yes. For lack of a better term, it's just It's something they have to do. The same way that I am not like I shouldn't have to understand how SQL pages data into memory in order to write a performant SQL query, right? With identity, however, especially as it is now with OAuth and OpenID connected, they can be fairly complex. And because there's so many things happening in so many different places, it can get pretty confusing pretty quickly. So I think what we see is not so much that we don't necessarily see lots of bad implementations as much as we see a lot of confusion in implementation, or a lot of confusion in when to use what for what purpose, which some of this whole learning path is geared towards trying to help make that a little bit less ambiguous. But I think that when you're dealing with identity and security stuff, there's always an element of it depends, and always an element of complexity that in some cases, at least right now, is pretty unavoidable. And so because of that, that seems to be a pretty common stumbling block for a lot of folks. If we need secrets or tokens in our clients and code, how can we deal with this securely? Are there any well-known techniques?
Funny you ask. So many choices, but ideally, as we said, we don't want secrets at all in our solution. And me and JP coincidentally have done a fantastic session on how to create secretless apps using things like Azure AD and Key Vault to protect you. So if you need to store secrets, the recommended way is to use Key Vault to store that information and then use one of our Azure SDKs to call into that using things like managed identities and service principals to do the heavy lifting for you. So you never want to use your own account because they tend to be more elevated in terms of permissions and they can do more damage. You want to have a service account, a service principal account backed by Azure AD that has very limited scope to go and pull the secrets from Key Vault and then bring them to your application. That includes client secrets for your Azure AD configuration. If you have to do that for whatever reason, you can use certificates. So we have blog posts, we have a couple of sessions on YouTube on how to create secretless apps and how to use it end-to-end to make sure you secure your apps. Ideally, if you follow me and JP, you know that we're very much against using secrets in our applications. We try to help developers do that. And for us, because we love and work on Azure, the best way to do it is through Key Vault. There are other ways as well, like if you're running on web apps, you can use app settings in your web app to store those secrets. These days, you can also back them up with Key Vault and Azure Active Directory. So again, double security there, but never ever leave secrets lying around in your code like you saw me and JP doing in the demo today. These have already been wiped out on my end, at least. Just to let you know. But that's the way to do it.
Yeah, Key Vault's a big one for arbitrary secrets for sure. Mm-hmm. If you notice, we created this console app. This console app has a secret. That secret's going to expire tomorrow, right? Because I said it to expire tomorrow. It could also expire at some arbitrary time in the future. It could be 6 months from now, 9 months from now, whatever. And so in production, for larger customers who have like certificate authorities and have good certificate authority hygiene, we suggest using certificates as much as possible because not only are certificates more secure in the sense that you're not going to be sending private data across the wire or sending actual secrets over the wire, but also because a lot of organizations that have a CA, have a certificate authority, have good hygiene and governance around that CA. So they're going to know the secret's about to expire. It was issued to these people. It was issued for this purpose. We store it in the Windows Search Store. We have lots of different ACLs on these certs in the server that the application is running. Like there are all sorts of ways to sort of secure that data. And then beyond that, of course, there's managed identity. And managed identity, which you mentioned, Christos, is all about if I've got an Azure resource, why shouldn't I just be able to give an identity to my Azure resource and let the Azure resource get its own tokens? And so in the case of managed identity, this is where things like a VM or Azure App Service or Azure Functions or a few different other things, an identity is created for them, just the same way that we have our client ID and our client secret. The identity is created for them, but your application never has access to the secret. Your application calls an endpoint that's local to the service, be it app service or VM or whatever. It calls this local endpoint, says, hey, I need a token for XYZ, and then that local service is the thing that actually delivers the token to the code, and then the code goes and does it. So the secrets themselves are auto-rotated, they're all certificate-backed, and they're auto-rotated and managed by Azure, hence the name Managed Identity. And so because of that, managed identity is great for bootstrapping, say, getting other secrets out of Key Vault, because instead of you having to have a secret to get into Key Vault, which just kind of kicks the can down the road, use a managed identity that represents your VM or your web app or whatever, and use that identity to go talk to Key Vault, get secrets out, and then use those inside of your code. And now you don't have any secrets in your code at all, with the exception of in memory when you go and pull it down from Key Vault. Top tools and tips for debugging identity and auth issues. A really good understanding of HTTP is the first place I would start. Yep. Your browser dev tools is another good place to start. Fiddler. And Azure AD logs, of course. Azure AD logging in general should be good. But I think understanding how HTTP works, particularly with the different payloads that get sent back and forth, how the cookies are going to be written and all that sort of stuff, I think that's a big help. and then understanding maybe to a degree how the protocols work. So in the case of OpenID Connect, there are lots of requests and calls that happen, things like we go get metadata. That metadata comes from a certain well-known endpoint that's constructed based on other pieces of data. And then that has pieces of data within it, like the JWKs, the JSON Web Keys URIs, which have the signing keys that are used to sign those tokens. Well, could I get the issuer metadata, or could I get that metadata in the first place? Could I get the key data? Is the key data correct? And then, okay, what does my application code do with that key data? Well, it goes and does all these things to figure out the signature and make sure the signature is valid. Well, what is a valid token? So I think, as at least for me, for now, the best debugging tools are just understanding enough of what's happening under the hood in order to be able to try to pinpoint where things fail. Because for better or for worse, it is sort of a 17-step process to actually get a token issued and back into your app, right?
Mm-hmm. Yeah. That's very much the experience, and you build it up the more you do it. Unfortunately, not many developers tend to spend too much time with Azure AD. They will try to do it and then move on to the next task, whereas me and JP do it day in, day out. So we're a little bit more accustomed to seeing those error messages and responding without freaking out. Although I do still freak out every time I get an exception from Azure AD because like, oh, what's broken this time, right? There's a fantastic question from Andrew, which I can't remember how to do it, and there's definitely a way to do it for Microsoft. So, is there a way to review code or infrastructure, etc., to highlight where a user may have left secrets in code? Now, I know we have, is it CredScan that we have a tool internally at Microsoft? I get emails at random intervals that my code that I checked into GitHub still has credentials, which have expired, of course, or they're not valid anymore, which I deleted. But occasionally I get scans and emails saying, hey, your code still uses some credentials over there, go and delete them. I would say if you don't have any automation tools, if you're not on GitHub, have a very rigorous process for check-ins. So as part of your pull requests, make sure that you go through app settings and try to look for credentials that may have leaked into the code. I would say by default, try to use Key Vault if possible with mass identities or service principals, as JP said, to also remove those secrets as part of your code practice and not as an afterthought. And then for existing code bases that you can go back and change, I think there are bots on GitHub that you can enable. JP, do you know if there are any? Like I know CredScan is for Microsoft, but I don't know if it's available to everyone.
CredScan was in preview for a while in Azure DevOps, but it is no longer. There is a CredScan-like tool that scans GitHub repositories, but it requires an extra GitHub license called GitHub Advanced Security. And then there are also some OWASP tools for there's OWASP keeps a list of various tools. Most of them plug into your pipelines of some kind. Either they scan your repos, or they scan check-ins, or they scan they do static analysis on binaries or whatever to find secrets where secrets do not belong. But yeah, there are lots of different things, but most of them are happening pre-deployment. I haven't seen a ton of stuff that goes and scans active machines to say, oh, it looks like you've got a secret and it's got 777 permissions on this. You've got 777 on this file, and that sort of thing. I have not seen a whole lot of those, but I'm sure they exist somewhere.
There are hacking tools out there. Hacking tools out there that will allow you to do that. In fact, there are bots right now that scan GitHub on a daily basis to try to find side keys and PGP keys and what have you. If you are going to use any of these tools, please only use them for your repositories and your own code, because you can land in some serious trouble if you scan somebody else's repos and grab those credentials. It happened before. So
our favorite,
be wise. Go on.
We had a great website. There was a great website out there that was a live updating feed of all the secrets that had been found in GitHub, kind of as a point to say, you can upload a secret and it will be, somebody will have it within minutes, if not faster. And they've sadly taken that site down because they said it was being abused. Imagine that.
Why? I don't know why.
Who could have guessed? So I can't remember the name of it now, but it was a cool site. But yeah. So yeah, that's where I would start.
There you go, man.
So, any more questions before we
Nothing on teleprompter, so I think we covered everything. Let me see if we have anything on tweets that has had its own kind of conversation on the side. Nothing on tweets. I've managed to answer everything there. And some of our usual friends, Phil Snubble, Chilaxathor is there as well. Sean.
Very nice.
Sean was there for a little bit. Thanks everybody for joining us on tweets as well, and every single channel that we are broadcasting today. It's been fun. Next week, I will probably be driving with a different wingman. JP is going on holiday. We're very well-deserved holiday after a super busy month. So come and join us next week as we look into the permission framework and the consent framework and why it's important and how you should set it up for your applications to make it less invasive for your users and more secure for your applications. So have a, oh yeah, Retro 595, you're late, but it's all recorded. It will be on YouTube afterwards. You can always join us. And the whole point is for you to go and do it yourselves and go through the experience and reach out to us if you have any questions. So make sure you go and complete the Learn module yourself and have some fun. And we look forward to seeing you next week. Thanks, everyone.